In this video, we're going to go through a quick introduction of how economists like to graph their data, or how they will often graph their data. All right. Please don't forget, like and subscribe, share the video with your friends if you find it useful. If you have suggestions for further videos, leave a comment down below. Okay, so let's start with two of the most common ways to graph economic data. And those are referred to as cross-sectional and time series. All right, so let's start with cross-sectional data. All right, so cross-sectional data is defined as a set of observations of a variable. So this can be, housing prices, average salary, the price of a certain good, the quantity produced of a certain good, whatever. A set of observations of a variable made at the same time, okay? Very important, made at the same time across different units. Okay? Now, what's a unit? It can be households, firms, countries, etc. All right. Now, what might be an example of cross-sectional data? We can have, for example, 4 different neighborhoods, and we want to know what the average price of a house is in those different neighborhoods in a given year. All right. So let's say we're talking about the year 2010. All right. And we're talking about 4 different neighborhoods. Okay. We could call these I don't know. Okay, well, this is not going to be very creative, but neighborhood 1, neighborhood 2, neighborhood 3, and neighborhood 4. So, whoa, I am misspelling the word neighborhoods. I hope that is correct. Okay, neighborhoods. And then, of course, on the y-axis, we will just have price, or your average home price, right? And now you'll have, of course, you'll have different values along this axis. So maybe this is in thousands of dollars. Okay, so you might have 100,000, 200,000, 300,000, 400,000, etc., right? And then you can represent your data using bars. So I'm sure you've seen data represented like this before, right? So the idea behind a graph like this, the reason that it's cross-sectional, all right, is that you have a set of observations of one variable, okay? Our one variable in this case, is average home price in thousands of dollars, right? Made across different units. And the units are the neighborhoods. All right, neighborhood 1, 2, 3, and 4. Now, looking at this graph, you could say, okay, the approximate average home price in the year 2010 in neighborhood 1 is just under $200,000. Okay, for neighborhood 2, it would be a little bit under 400,000, right? Maybe 375,000. In neighborhood 3, it would be, well, I don't know, let's call that 80,000, right? And then in neighborhood 4, it's quite a bit higher, so that would be just under, well, maybe 560,000, it's 570,000, something like that, right? The idea is you want to compare the price of these neighborhoods at a given point in time to know, okay, which of these neighborhoods was most expensive and least expensive in 2010. Now, of course, neighborhood 4 would be the most expensive, neighborhood 3 would be the least expensive, okay? So that's an example of cross-sectional data. You have one variable, in our case, home prices or average home prices, and you're comparing that variable across different units, but at one set point in time. Okay, this is as opposed to time series data, which are almost the exact opposite. Time series data, which are a set of observations of a variable, so it's still of one variable, but this time that variable is being measured across time. Okay, so the observations of a variable made at successive periods of time. Okay, so what would be an example of this? Well, the classic example, often used in textbooks, so I'll just use it here, is unemployment rate. Okay, so what is the unemployment rate of some country across time? All right, so let's say unemployment rate in USA from 1950 to 2010. Okay, and I am warning you that these are going to be completely made up. All right, they have no basis in reality whatsoever. So along our y-axis, we will plot the actual unemployment rate. Okay, so unemployment rate is here, right? And it'll be in percentage terms. And then on our x-axis, we'll have the year. Okay, so we'll plot every year. 1950, maybe this is 1955, 1960, etc., all the way up to 2010. And then we might have a graph that looks, oh, sorry, forgot this, unemployment rate. We might start it at, well, okay, 1, 2, 3, probably unlikely to be that low. 4, 5, 6, 7, sorry that these are not even, but you're getting the picture, 9, etc. And then you'll have, you know, something like that, right? So what this graph represents is the changing rate of unemployment, right? That's our one variable, right? Variable in this case is the unemployment rate over successive periods of time, right? So our periods of time are 1950 to 2010. What, right? One data point for each year. Okay, so that's time series data. And then finally, well, not finally, there are many ways of representing data, but for the intro level, usually these three are the ones that professors usually emphasize and textbooks usually emphasize. We have scatter diagrams. Okay, now a scatter diagram, I've actually used a scatter diagram in a previous video, so maybe I'll just use the same one here. So, scatter diagrams. So scatter diagrams are just meant to represent the relationship between two variables. Okay, so a scatter diagram has two variables. Okay, one on x-axis, one on the y-axis, right? And each point on the graph represents quantities of each variable for one observation. All right. So let's go back to our example that I did in a previous video with sleep time correlated to number of liters of coffee that the person drinks in a day or a week or whatever it is. Okay, so I believe we had liters of coffee. Well, liters is a lot, so this would probably be in a month or something like that. And then on the x-axis, we had hours of sleep, okay? And then we have a bunch of data points, right? So we might have something that looks like this, okay? Each of these data points represent one individual, okay? They don't have to represent individuals, but in our case, I'm just stating that they each represent an individual. All right, so basically, what can you tell from this scatter plot? Well, basically, a researcher went out and they said, sir or ma'am, let's take this person, call this person individual 1, and they said, how many liters of coffee do you drink in a year? And they answered some number, okay? And that number was this number here, call it Y. And they said, okay, and how many hours of sleep do you get in, I don't know, a year or a week or something, whatever, it doesn't matter. And they said, whatever number of hours this is. And that's how the researcher got that data point. And then they did the same thing for all of these other individuals. All of these other individuals. And they graphed all of these observations here. And as you can see a general sort of downward, a general downward trend line here, basically indicating that as the person gets more sleep, they also drink less coffee, or another way of saying that would be as they drink more coffee, they get less sleep. As we mentioned in a previous video, we don't know which way the causality goes, but that's not the point here. The point here is just to show you that this is a way of representing economic data. Okay, so those are scatter diagrams. All right, so that's it for this video. Like and subscribe if you find it useful. Share it with your friends, colleagues, classmates, and please, as usual, leave a comment down below if you have a suggestion for a further video, and I will do my best to accommodate. I'll see you in the next video.